So for giant ionic compounds, they are electrolytes. That means they can only conduct electricity in molten state and aqueous states. They are soluble in water, of course. Most of them are soluble in water. We will learn about which of them soluble and which of them insoluble in later chapters. They have high melting point and boiling points, hard but brittle. That is a little bit different with giant covalent structure. Giant covalent structure, they are hard but not brittle. So this is a typical model of sodium chloride, but not all ionic compounds will have this kind of structure. For example, cesium chloride will have another structure. You may refer to the notes of chapter 7. So for a giant metallic structure, it is hard, good conductor of electricity and heat, high density, high melting point and boiling points. They are malleable and ductile. So for the structure, I will explain in the next slide. Okay, for metallic structure, all the metals will lose its electrons to become delocalized electrons, and the cation have the metallic bond with the electrons. So these kind of the structure are repeated for all the metals. So in a giant metallic structure, they are usually good conductors of electricity. Before connecting to a battery, all the electrons can move in random directions. However, when it is connected to the battery, the delocalized electrons move towards the positive pole of the battery, leaving the metals. At the same time, an equal number of electrons will move into other end of the metal from the negative pole. So electrons are responsible for the electrical conduction. So for the metals transferring heat, it is in a similar principle. When the heat source hit one end of the metals, the electrons here gain the energy and it vibrates more vigorously. So it will hit another electrons, then these electrons will gain the energy. So that's why this electron can move at a higher frequency. So it will have the chance to hit another electron. So the heat is passed in this way, using the delocalized electrons. At any moment, the number of electrons in the metal remain unchanged. There is no chemical change when the metal conducts electricity. So if you still remember, if electrons going out one side attracted by the positive pole, at the same time, the same number of electrons will go back to the negative pole. So that's why the number of electrons in the metal remains unchanged all the time. So most metals are solids with high melting points and boiling points. That is because a lot of energy is required to break all the strong metallic bonds in giant metallic structures, so that the ions will be broken into particles, broken into the separate particles. So tungsten has a very high melting point. It is used as the metal filament in a light bulb. So this one is a little bit difficult to explain. Metals are malleable. That means can be rolled into sheets and other shapes. And ductile can be pulled out into wires. So originally metals are packed closely. They're solids packed closely. The metal atoms will pack closely together. But the metal piece does not break because the non-directional metallic bonds continue to hold the metal atoms together. When a great force hits the metals, since the electrons can slide, it can slide. So that's why the atoms move, but at the same time the electrons also move. The metallic bonds does not break. So that's why the metals can change shape easily without breaking the bonds. So for the summary, you should be able to identify its structure by its unique characteristics. For example, simple molecular structure, its unique characteristics is having low melting point and boiling points. For giant ionic structure, its unique property is to conduct electricity in molten state or aqueous state. For giant covalent structure, since it is different for 3 different giant covalent structures, usually we will keep it at last. We will check whether it is giant metallic structure first. For giant metallic structure, it is the only structure can conduct electricity at solid state. Okay, so that is the unique characteristic of metallic structure. And then at last, if all the 3 properties are not matching, then usually that structure will be giant covalent structure.